Hello. Um, Today we will see the powers of integers and their properties. So let's start seeing the concept of power. So if I write this is a power. The big letter is going to represent a number. Okay, so this is going to be any number, positive or negative number, and this is called base. So base is the big number, and we have a small number n called exponent. So the power is a product where the factors are the letter A. Okay, so how many times do we have to multiply the A? So many times as the exponent says, so n times. For example, if we have 3 to the power of 2, this is the same as 3 times 3. Okay, 2 times, we multiply the 3 2 times, so this is 9. We have 2 to the power of 4, we have to multiply the number 2 4 times. 16. We can do the same with negative numbers, minus 2 to the power of 2. This is minus 2 times minus 2. So if we multiply two negative numbers, we get a positive number. This is 4 or positive 4. Another example, minus 2 to the power of 3. Minus 2 to the power of 3. This is negative 2 times negative 2 times negative 2. Okay, so to multiply this, we can start multiplying the two first numbers. Negative 2 times negative 2 is positive 4 times the remaining number times minus 2, this is minus 8. So from here, from these two powers, we can get a very important rule. Okay, so I'm going to write the rule here. So imagine that we have a negative number, so I'm going to write minus a, okay, to identify this negative number to the power of n. So we can get in all these powers two different solutions. We can get a positive solution when the n, the exponent, is even. For example, 2, 4, 6, 8, etc. Or we can get a negative solution if n is odd. For example, 1, 3, 5, 7, etc. To see the two different options or two different cases, you can see this operation here, minus 2 to the power of 3. So 3 is odd, and I have here a negative number. So the solution will be negative. So we are in the second case, negative solution. And the first operation, 2, this 2 is even number. The base is negative, so we get a positive number. We are in the first option or first solution, the positive solution. Okay. So after this, we are going to see some important rules of powers, some important properties. So we will see any property with examples. Let's start. First property. If we multiply two powers, with the same base, this is the same as the same base, and in the exponent we can add both exponents. For example, let me see an example. 2 to the power of 2 times 2 to the power of 3. This is the same as 2 to the power of 2 plus 3, 2 to the power of 5. Let's see if this is correct. Okay. 2 to the power of 2 is 2 times 2, this is 4, times 2 to the power of 3 is 8. So this is equal to 32. So we come back to our solution, 2 to the power of 5. This is 2 times 2 times 2 times 2 times 2. And this is certainly 32. Okay, so we get the same solution. Let's continue with the second property. If we divide two powers with the same base, this is the same as the same base, and in the exponents I have to subtract them. So n minus m. Let's see an example. 3, or I can write also negative numbers, minus 3 to the power of 2 divided by minus 3 to the power of 1, to the power of 1. This is the same as minus 3 to the power of 2 minus 1. So minus 3 to the power of 1. Okay, and this is the same when you have exponent 1, is the same as writing only the base, minus 3. Okay. Another property is any number to the power of 0 will be 1. Okay. And any number to the power of 1, is this example here. Any number to the power of 1 is the same number, is the same base. Okay. Next property, we can have also two powers together. Let me write a to the power of n in brackets and to the power of m. Two exponents together. So in this case, this is the same as a to the power of n times m. Let's see an example. Minus 2 to the power of 2. I'm going to make square brackets now. And to the power of 3. This is the same as minus 2 to the power of 2 times 3. So minus 2 to the power of 6. This power minus 2 to the power of 6 is the same as 2 to the power of 6. Why? Because when you do this power, we have a negative base, so negative base, and the exponent is even. So we are going to get, if we do this operation, we are going to get a positive number, plus 64. Okay? if we do the operation with the positive numbers, we are going to get also plus 64 or only 64, okay, without the plus, without the positive. So this is equal. So we can write both solutions. And let's see the last property. The last property. Be careful with this. Be careful with this, because it's very easy to confuse with the first property. We have also a multiplication, but not with equal basis. We have different numbers now, but the exponents are the same. So this is the same as multiplying the both bases and to the power of n. Okay, and pay attention to this, because I'm not multiplying the exponents. I'm writing the same exponent. I'm going to write an example. 2 to the power of 5 times 3 to the power of 5. So this is the same as 2 times 3. This is 6 to the power of 5. Okay, and I'm not going to calculate the number because it's very, very big. Okay, you can write the solution. You can write the solution as a power, no problem. Okay. Sorry, I forgot writing another. Well, in the product here. Okay, I forgot writing this this property with the division. It's the same. Okay, it's the same, but we have to divide the bases here. Okay. Let's see some examples. Let me change the color. Okay. So, for example, we are going to write in square brackets 9 to the power of 3 divided by 3 to the power of 3. I close brackets and all this to the power of 2. And outside or after the brackets, I'm going to write times 3 to the power of 2. Okay. So let's see how to do this operation. So we have brackets, square brackets, and inside we have a division of 2 powers. And these 2 powers have different bases, but we have the same exponents. Okay, they are the same. So we can divide both bases. So I make the square brackets. So I can do 9 divided by 3, 9 divided by 3, and the exponent will be 3, the same. Okay, I close the square bracket to the power of 2 times to the 3 to the power of 2. So the square brackets is 3 to the power of 3. I close brackets to the power of 2 times 3 to the power of 2. Now I have inside the brackets 1 power, and outside the brackets I have another exponent. So when you have 2 exponents, you must multiply both exponents. So 3 times 2 is 6. Okay, so 3 to the power of 6, and finally this is 3 to the power of 8. So that's everything. We will do more operations in class. Bye bye.